Let's get started with the notes for section 1.2, laws of exponents with quotients. As you can see here, our objectives are that after we're done with this lesson, that you should be able to simplify expressions using the quotient of powers property, and that you should also be able to simplify expressions using the power of a quotient property. All right, so this note sheet starts off with some warm-up, some practice problems from the previous lesson. Okay, so take a moment right now to go ahead and see if you can find the answers for these three problems. Okay, go ahead and take the time here to check your answers for these first three warm-up problems. Again, if you have any questions, make sure you ask during class. Okay, so now we're going to move on to discussions about the quotient of powers property. Before we get into those specific examples, let's remind ourselves, what does it mean to cancel in math? Again, it means that we're reducing the fraction by like factors in both the numerator and the denominator. Okay, so if you take a look at example A, right, so we're going to rewrite the numerator and denominator in its completely factored form. So 12 is 2 times 2 times 3, and 15 in the denominator is 5 times 3. Right, so that we can, because we have like factors in the numerator and the denominator, we can go ahead and cancel those, leaving us with a reduced fraction of 4/5. All right, doing the same thing here with 30 over 45. Okay, writing 30 in its completely factored form, 2 times 3 times 5, and 45, 3 times 3 times 5. Okay, we have like factors in the numerator of 5 that we can cancel, and also like factors of 3 that we can cancel. All right, so that's going to allow us to reduce that fraction down to 2/3. All right, so moving on to the next part of the notes. It says here, expand the numerator and use the canceling method to simplify the expressions. All right, so use this to derive the quotient of powers rule property. All right, so we're going to rewrite x to the 7th as x times itself 5 times, and then denominator x to the 4th as x times itself 4 times. Okay, so now that we have both the numerator and denominator in its completely factored form, again, we can go ahead and look for like factors to cancel. So we can go ahead and cancel that. Another pair, 3 pairs, 2 pairs of x's. All right, so we got 4 pairs of x's that we can cancel, leaving us a numerator of x times x times x, or just x cubed. All right, again, we can do the same thing with part B. All right, it's going to be a times itself 3, 4, 5, 6, 7, 8, 9. And then denominator, x times itself 7 times. 1, 2, 3, 4, 5, 6, 7. All right, let's go ahead and cancel like factors. So these cancel. 2, cancel. 3, 4, 5, 6, 7. All right, so those like factors cancel, leaving us with a squared for this one. Okay, so let's go ahead and do part C on your own, and then maybe try to come up with a rule. It says, okay, how can we get the simplified exponential expression without having to expand the numerator and denominator every single time? Okay, so for part C, right, we got 8 factors of b in the numerator, and we also have 8 factors of b in the denominator. Okay, when we cancel all of those factors, like factors, now you gotta be careful, right? It doesn't reduce down to 0. Right here, it's going to reduce down to 1. Okay, so we got to make sure we're careful that we do not write 0 when everything seems to cancel out here. All right, so maybe some of you have figured out that, hey, when it comes to these quotient of a powers situations, again, we're thinking about like bases. All right, so for our final answer, we're going to keep that base, and then for our exponent part, it's going to be the difference. So the top exponent minus the bottom exponent. All right, so again, we kind of go back to our first example here, right? Following that rule, We have x to the 7th divided by x to the 4th. We keep the base of x, and we're going to subtract 7 minus 4 to get 3. Right? Part B, we keep the base of a. 9 minus 7 is 2. Here we keep the base of b. Right, so maybe we write it this way. Keep the base of b. 8 minus 8 is 0. So again, if you recall, anything to the 0 power leads you to a value of 1. All right, so go ahead and take the time to see if you can apply that rule to these next 3 examples, and we'll come back and check your answers here in a minute. All right, applying that quotient of a powers property rule. All right, so when we are dividing exponential expressions with the same base, we're going to keep that base and we're going to subtract the exponents. Okay, so we do that for every one of these. Again, a reminder, if you see a variable without an exponent, right, the exponent is assumed to be 1. Okay, so here we have y to the 4th divided by y to the 1st. So we apply that rule, you get y to the 4 minus 1 exponent, so y to the 3rd when it's all said and done. And again, remember we're applying the rule here to exponential expressions with the like bases. Okay, so we do that with the x's, we get x to the 4th, the y's, y to the 1st, or just y, and here the z's, we get z to the 8th power. All right, so with this next section, we're going to talk about the power of a quotient property. All right, so we're going to step back here for the first 2 examples and see if you can figure out the answers on your own. Again, you're going to simplify each expression to the best of your ability. What do you think is the main difference between these 2 problems? Okay, so again, we're trying to simplify these 2 expressions as best as we can. All right, so we're back. Let's take a look. Again, in the numerator. So in the numerator, we have that power to a power situation going on there. All right, so again, we see this exponent of 3 attached to the parentheses, which says the base to that exponent is x squared. So again, we're going to apply the power to a power property there. So we're going to multiply those 2 exponents. We're going to keep the base of x. 2 times 3 is 6. Now you notice that the y to the 4th was left unaffected, right? Again, there was not, that 3 of an exponent was not applied to y to the 4th as a base, okay? So keep it as that. Now we can't do anything else with this expression, right? Again, a lot of the properties we've talked about so far involve exponential expressions with like bases, right? X and y, definitely not like bases, so we're not going to do anything with these exponents. Now you move on to part B. All right, so now there's that exponent of 3 again. However, that 3, again, as an exponent is attached to parentheses, which is telling us, again, everything inside the parentheses is considered the base to that exponent. Okay, so that means the x squared that's here in the numerator of that base, right, that's going to get that 3 as an exponent. And also that y to the 4th in the denominator of that base is going to get that 3 as an exponent. Okay, so again, we're going to rewrite it like that, like this right here. All right, and then we're going to see, yes, we have a couple scenarios of power to a power, so we apply our knowledge of that. So we get x to the 6th in the numerator, power to a power, y to the 12th in the denominator. Okay, so let's take a look at the next 2. We want to go ahead and develop some sort of rule. Okay, so here we got x over y to the m power. Again, the way you can evaluate that is, right, kind of distributing that exponent inside the parentheses. So we have x to the m over y to the m. Same thing over here. Again, the slight difference here in that the base are a couple exponential expressions. However, again, we can still come up with a rule, x to the a times m over y to the b times m. Okay, so let's see if we can apply what we learned here today with the lesson. Okay, so I'm going to pause the video and give you some time to work on these 5 examples, and then we'll come back together to kind of check your answers. All right, again, anytime as you're going through this, if you have any questions, make sure you ask in class. All right, so let's take a look at your answers for these examples. Starting with part A, so now you got to be careful with the negatives in here in the base. Okay, again, because that negative is making that fractional base negative. So a strong suggestion is to take that negative symbol and apply it to either the numerator or denominator. Again, it doesn't matter which one you do it to, just make sure you're only doing to one of those two. All right, so when I do that, move that to the 7, then I can apply that property that we talked about earlier. So it's going to be -7 squared over x squared. All right, when we square -7, we get a positive 49, and then over x squared. All right, so now take a look at part B. Not sure exactly what approach you took, but here's a suggestion, right? And I'll give you some time to copy this down. You might want to consider situations like part B where you might want to simplify what's inside the parentheses first, meaning applying any exponent rule possible. And here we're going to be using the quotient rule. All right, so again, that kind of minimizes, as you can see here, you know, what you're going to do with this exponent outside the parentheses, right? We don't want to have to distribute that, quote unquote, distribute that, right? Too much, right? That's a lot more work than we want to. So let's go and take the time to reduce what's inside the parentheses. So 4/6 reduces down to 2/3. I can use the quotient rule here again with the x's to get x to the first. Same thing with the y's to get y to the first. Okay, so again, as you can see, that minimizes what I have to do with this exponent of 2 outside the parentheses. All right, so again, applying that property and doing a little simplifying, I get 4x squared y squared over 9. All right, part C. Okay, so I'm multiplying here a fraction times something that's not a fraction. So again, in situations like this, we can rewrite that y to the 15th as a fraction, right? Just putting a 1 underneath. And again, when you multiply fractions, you multiply straight across. Right? So I get y to the 15th divided by y to the 8th. All right, so that's going to give me, when I use that quotient rule, y to the 7th. All right, so you take a look at my work here for D. All right, so I'm going to go ahead and distribute that 5 through as an exponent. All right, use that quotient, that power to a power rule to simplify that. Here, I'm multiplying fractions. And then I'm going to apply one more time here the quotient rule to get my final answer. All right, these last 2 examples. Again, here I'm going to go ahead and simplify what's inside that parentheses using quotient rule. Okay. And I did the same thing here with this fraction using the quotient rule, right? Trying to minimize the amount of work, the things I need to be looking at and dealing with. All right, so then I'm going to go ahead and distribute that exponent of 4 through. All right, simplify it. All right, multiply it to this fraction. All right, again, looking for opportunities to use an exponent rule. I notice here that with z to the 32nd power in the numerator and x to the 6th in the denominator, I'm going to use quotient rule. That's how I got z to the 26th. All right, we're going to subtract 32 minus 6 to get 26. All right, with this last example, again, using the quotient rule, I'm going to keep the base. I'm going to subtract top minus bottom exponent. So 5 minus 7 is a -2. So we get y to the -2 power. All right? All right, so again, go ahead and get started on the 1.2 homework. If you have any questions, please let me know. You guys have a great day.